Hey guys, we've almost made it to the finale. We're on day 10, and really outside of the intro to day 10 and day 11 are just review. And so we're going to take these next 2 days, today with day 10 and tomorrow with day 11, just to get you ready and to make sure we answer any questions you have before our test. Now, I'm going to warn you, day 10 may be one of the longest days of the chapter, but I'm going to try and keep things quick and breezy. And I'm also going to open up the chances for you to skip videos and kind of bounce around a little bit. But I think it'd be very, very imperative that you take some time to make sure you work on a lot of these individual problems. And make sure you're on the lookout for when I show this right here, because right now I'm working with Edpuzzle on getting my storage space expanded. So if you ever see me put this, you know you're going to pause the video and work on the problems that have been circled. This is for my people who don't have audio, which I guess if you don't have audio, you can't hear this right now. All right, so day 10. Only one new topic today before we jump right into review of chapter 1. So our only new standard, we're talking the fundamental counting principle. And I know that sounds a little bit scary, but all that means is it is an easy, I repeat, an easy way to determine the number of possibilities. And the reason it's so easy is because if you're trying to find out the number of ways different options can happen, all you're going to do is multiply the number of each option. That is all there is to it. So, for example, there are 2 types of hats and 2 types of jackets. Therefore, you take 2, multiply it to 2, and you get 4 total combinations that are possible. So take a look. Sandwich shop offers 3 types of bread, 2 kinds of cheese, and 5 deli meats. We can choose, here's the key, we can choose 1 type of bread, 1 kind of cheese, and 1 deli meat. So what that means is we've got on part A, how many different sandwiches can you order? So part A, we're ordering 1 type of bread, 1 type of cheese, and 1 kind of meat. So we get 1 of each. Now, there are 3 types of bread, 2 kinds of cheese, and 5 deli meats. So 3, 2, and 5. Now, what that means is we know if we're trying to find the number of total combinations, how many different sandwiches can we order, it goes back to the fundamental counting principle. So we are going to multiply. So 3 times 2 times 5 says, 3 times 2 is 6, 6 times 5 is 30 different sandwiches. So you have 30 different combinations we can make there. Now here's where things get a little interesting. Part B. How many more sandwiches could we order if we were allowed 2 meats rather than 1? So now we've got 1 bread, 1 cheese, 1 meat, but then we get another meat. So now we've added an extra elements here because we're allowed 2 meats instead of 1. Now our options are still the same here. 3 for that, 2 for cheese, but we also could get 5 options for that meat and 5 options for that meat. So let's see how many more options this gives us. 3 times 2 times 5 times 5, that is 150 different sandwiches. But the question was, how many more? How many more sandwiches? So we take 150, subtract 30, and we see we get 120 more sandwiches. So that's kind of what this is about, guys. So what I'm going to let you do is I'm going to let you guys try number 2 for me. So you can pause the video and work on the problem circle. So Jonathan has 8 different shirts, 5 different pairs of jeans, and 2 different vests. How many different outfits can he make? Well, using the fundamental counting principle, we know all we have to do is multiply all the possible options. So 80 different outfits. Now the one note I'm going to make, guys, before we jump into our review, is that when it comes to people, things are a little different. You notice up here how, like with whenever we involve 2 different meats, we said it's still 5 options, no matter what, 5 different kinds of deli meat. Well, people are different. Whenever we're talking about people in positions, there are no repeats. So guys, people in positions, there are no repeats. So for example, we have 7 golf players, so 7 total players. Now, the coaches will pick a captain, a manager, and a scorekeeper. So here's the thing. Let's say we're talking the captain first. So how many players could be a captain? Well, 7. But then a manager. Here's the thing. 1 player is now there. 1 player is now, there. Which means now for the manager, you only have 6. 1 player is now that. Which means for the scorekeeper, one player is now a scorekeeper. And so when you look, you say, wait a minute. So once I choose a captain, that means I only have 6 players left. And of those 6 players, 1 will be a manager. Once I pick that, I now have 5 players left. And one of those 5 players will be a scorekeeper. Because people in positions, there are no repeats. You can't have a person be the captain, the manager, and the scorekeeper. You can't do it. So 7 times 6 times 5, we're talking 210 options. So now we get to another example here that you guys can kind of see involving people. And the big thing here is no person can hold more than 1 office. So I'm going to let you guys try number 4. You can pause the video and work on the problem. So on number 4, we see that we have 22 members of this club. Now, any member can be elected to any position, but no person can hold more than 1 office. So to start, we know all 22 people could be president. But once somebody is the president, that means there's only 21 people left for vice president. Once somebody's elected for vice president, only 20 people can be left for historian, and so on and so on. And when you multiply this out, you find out that there are 175,560 different sets of officers. Whoa, that's insane. That's how crazy these combinations can be once you start dealing with more people and more positions. So, on to the next page. Now, we're going to do 1 more of these, and then I'm going to let you guys kind of flex and see if you're feeling pretty good on it. The one thing we have to watch out for is repetition in categories. So, for example, categories only count once. So take a look at number 4. We're looking at the options for a college's science classes are shown. And so we want to know how many combinations of class, type, and times are available. So that is three things there: class, type of grade, and times. So we've got class, type, and times. Now, at first, you're probably thinking, okay, this is really straightforward and easy. And it is, as long as you catch the one tricky part here. We have three different classes. We have three different times, but we only have two different types of grade types. So be careful there. It's either pass or fail or letter grade. That's it. So when you do your multiplying, you find out 3 times 2 is 6, 6 times 3. There are 18 different combos. And you're more than welcome to try number 5. But this one is optional. So you can try number 5, but it is optional. And so if you're ready, we're going to be jumping into our review. I'm pumped. Okay, so there you go. If you want to see kind of what's going on there, 6 different televisions. All right, let's get on to the review of our good stuff here. In fact, we're going to kind of work our way backwards a little bit, starting with day number 9, when we talked about experimental versus theoretical. Now remember, experimental, based off results. Theoretical, based off what should happen. That's the difference here, guys. Experimental is based off actual results. Theoretical is based off what should happen. And so, for example, on number 1, they ask, what is the experimental probability of this spinner stopping on section A? Now, normally that would be 1, 2, 3, 4. That'd be 1 out of 4. But experimental means we've actually already done an experiment. After 12 spins, spinner landed on section A 4 times. So we got A 4 times out of 12. And so our experimental probability, the probability of A, would be equal to, so we're talking 4 out of 12, which reduces down to 1/3. Now that is our experimental probability. How about theoretical? So we know that is what should happen, and that's where we look at our picture. That's where this picture is going to come into play. And so we know A, 1, 2, 3, 4, A is the same size as the rest of these. So the probability of A, hypothetically, is going to be 1 out of 4. So we actually, based off our experiment, these are the better odds. We had a better odds of getting A in our experimental than we did theoretically. Now, as far as numbers 1 through 3 on this page are concerned, these all come from day 3. So if you're curious, numbers 1, 2, and 3 all are from day 3. And really, we just had a Delta Math and a quizzes over these as well. So as far as dealing with SegAd Post is concerned, I'm hoping you guys are feeling pretty confident about it. But if not, let's do a couple quick ones together, and I'll let you guys try one on your own. So find the length of segment DE. So we know we got DE. And again, if you want to know how to handle these easily, draw a picture. I cannot stress that enough. Draw the picture. So if D is between points C and E. Oh, well, see, that's the problem here. D is between points C and E, which means C is over here. You see how easy that is to mess up? D is between these, so C and E, D in the middle. Now, we don't know that that's a midpoint, so do not do that. Not a midpoint. We know CD is going to be 6.5 centimeters. And CE, the whole thing, is going to be 13.8. So our question is, find the length of DE. So find this piece right here. Well, part plus part equals whole. Seg, add, post. That's going to be our savior here. Part plus part equals the whole. So let's call DE, let's call it X from here to here. So we've got 6.5 plus X equals 13.8. Subtract 6.5. And again, this is a one-step algebra problem, guys. So I feel pretty good about your odds on this one. And we end up with DE being 7.3. And what do you notice here? They're not the same. So we can say DE is not a midpoint. That is incredibly important, guys. We cannot assume that that point is a midpoint unless they tell us, or we discover it algebraically. Now, I'm going to let you guys try numbers 2 and 3, and pay special attention. Again, not told midpoint, but here, RS, ST. That means S is a midpoint. So you can pause the video and work on these problems. 2 and 3. So real quick, guys, we have part plus part equals the whole. And down here we've got this piece and this piece are congruent. So if that's 6 plus 8, that's 6 plus 8. So 6 plus 8 plus 6 plus 8 will equal the whole. So you guys can keep on working if you're not done, or if you need to correct that. You can see if you can finish this problem out. Okay. So once you solve this out, combine your variables together, 4x and 2x. So I brought 2x over. 7 plus 8 gives you 15. Subtract 3, bring that over to 15. 2x over to 4x. You get 2x and 12. Divide 12 by 2, x is 6. But that is not what they wanted us to find. We wanted to find the length of segment XZ. That's the whole thing. So we take x, we plug it in to that x, and XZ is going to be 4 times 6 plus 3. Get that from right here. And that's going to be 27 units. Now, number 3 is a lot less work. We see S as a midpoint, so that and that are congruents. So we can add part plus part equals the whole. Work it out. 6x and 6x is 12x. 8 and 8 is 16. Subtract 16 over and divide by 12. X is 3. Now, we have done 4 and 5 on a quizzes and delta. So 4 and 5 are going to be review. This is big review. So one thing I'm going to tell you here is that the distance between A and B, make sure you get these coordinates right. That's 0. So A is at 1, 2, 3, negative 3, 1. B is at 1, 2, 3, 4, 1, 2, 3, 4. So, and we see B is at 1, 2, 3, 4, 1, 2, 3, 4, 4, 4. So keep that in mind on these, and then be careful because down here we find the coordinates of the midpoint of segment CD. we're talking different points here. We're talking 1, 2, down 1. So that is -2, -1. And D is 1, 2, 3, 4, 5. 1, 2, 3, 4 down. So 5, -4. So be careful there, guys. We're talking two different things here. All right, so you can go ahead. The number one mistake people make, guys, is the setup on distance and midpoint. x2 minus x1, y2 minus y1. So be very, very careful. x2 minus x1 is 4 minus -3. y2 minus y1 is 4 minus 1. Double negative turns that into a plus, so that's really 7. 4 minus 1 is 3. So that plus that is going to give us the square root of 58, and that is approximately 7.6 units. That's approximately how far away point A is to point B. Now midpoint. Midpoint is an actual point. There's an X and there's a Y. There's two components. So here are our points. Here is C and here is D. And so we plug it in. The X of C plus the X of D. The Y of C plus the Y of D. All divided by 2, because we're really finding the average of the X's and finding the average of the Y's. And when you do that, you get 1.5 and -2.5. So hopefully you guys ran the table on those two. If you did, and if you've been feeling pretty confident so far, I'm liking your outlook on Thursday. And speaking of liking my outlook, we just have one problem left today, guys. I know today's been a little bit of a longer lesson, but I feel like we've gotten through it pretty quickly, actually. But let's finish strong here, and let's make sure we see what we're dealing with. So numbers 6, 7, 8, and 9 are going to be from days 5 and 6. So if you need to go back and look through these and you really struggle with these, those are your days to do it. So real quick, always read directions. Always read the setup, because they're going to tell us some crazy important stuff in the setup. Like, for example, ray EA and ray EB are opposite rays, so those are connected, and ray EC bisects FEG. That's huge. So EC, this one right here, bisects FEG. That means that this whole angle is split into even pieces because of this ray right here. And that's going to be huge for us a little bit later on. Now, name an angle that is supplementary with AEG. Supplementary means angles that add to 180 degrees. So angles that add to 180 degrees. So we've got, here's a straight line right here, 180 degrees. So AEG, that's going to be AEG. That's this angle right here. So what's going to add with that to give us the whole line? Well, AEG is this much. How about this much right here? GEB. Angle GEB. And we got 180 degrees if we do that. Name an angle that is adjacent to CEG. That word adjacent means right beside CEG. So here is CEG, this angle right here. Well, we could go with FEC or GEB. I'm going to go with FEC, since we know those are congruent angles anyway. So F angle, FEC, or, you know what, I'll include both. You could have gone GEB. GEB. How about this one? Find X if angle FEG, the whole, and angle FEC was 5x plus 11. So in other words, what they're doing is they're giving us the whole angle. They're saying here's the whole FEC, here's part, and they're saying, hey, find X. Well, we know part plus part's going to equal whole. So if this is a part, that means this is going to be a part too, part plus part. And we know that if these are the same, if that's 5x plus 11, that means CEG is going to be 5x plus 11. They're congruent. So in other words, this part plus the same size part is going to equal the whole. So we're going to get 5x plus 11 plus 5x plus 11 equals the whole, 82. And I will let you guys take some time to work that out. All right, you work that out. Add these together, 10x plus 22 equals 82. Subtract 22 over, and then divide by 6. So we know x is going to equal 6. Now this last one, if you don't know what this symbol means, this is going to be really confusing. That means perpendicular. So ED and AB. Here's ED, and there is AB. Now what happens is these form a perpendicular intersection, which means that is a 90-degree angle right there. So we got 90 degrees coming out of that. So if AED is 16y plus 10, AED, that's 90 degrees, find y. So we know that this whole angle adds up to be 90. Well, if this is what the equation is, or if this is what one half of the equation is going to look like from that angle, 16y plus 10, we know this angle is equal to 90, so we can set it equal to 90. And just solve for y. This and this are congruent. They're the same thing. So we work it out. Subtract 10. Divide by 16. Y is 5. And I'm not going to keep you guys because you've done a great job sticking with me. Again, most of our videos are not going to be anywhere near this long, but we got a test coming up, so I wanted to make sure I worked as much of this with you as I could to answer your questions. You guys know you can get in touch with me a lot of different ways. If you want to practice 1 and 2, these would be good practice. Now these are from, we're talking days 7. So 1 and 2 are from day 7. If you want some practice there. So if you guys need to get in touch with me, please do. You know how to contact me, and I will be talking to you guys soon.